Cylindrical coordinate system is one of the basic coordinate systems that you study in your electromagnetics. In cylindrical coordinate system, the point is represented by three coordinates: rho, phi and z. So in this video, let us see what could be the phi coordinate of any point which is present on the z-axis. In cylindrical coordinate system, we know that any point in the space is represented by three coordinates: rho, phi and z. What is rho? Rho is the lateral distance of that point from the z-axis, or you can say rho is the radius of the hypothetical cylinder that is passing through that point. Yes or no? And what is phi? Our point of discussion in today's video. What is phi? Technically, in cylindrical coordinate system, phi is defined as the angle made by the vertical half plane containing that point with the positive x-axis. Again, I am repeating. In cylindrical coordinate system, phi is defined as the angle made by the vertical half plane containing the required point with positive x-axis. The phi is angle between positive x-axis and that vertical half plane measured in the anti-clockwise direction. Yes or no? For example, let us say this is a point P present anywhere in the space. Okay, this is our point P present in space. So what will be the vertical half plane? Vertical half plane will be as like this. Vertical half plane is the infinite half plane whose one side is stuck to the z-axis. Vertical half plane is the infinite half plane. Why half plane? Because its one side is stuck to the z-axis, and that plane should contain your required point. So if this point is present like this, then vertical half plane containing this point will be as you can see from the screen. And according to our definition of phi, this angle, the angle made by this vertical half plane with the positive x-axis is known as phi. Very simple. So this is nothing but the phi coordinate, and this phi can take any value from 0 to 2 pi or 0 to 360 degree. Yes or no? If point is present as like this, then phi coordinate is as like this. If point is present as like this, then phi is as you can see from the screen. So what I am trying to say you, the phi coordinate can range from, the range of phi coordinate is from 0 to 2 pi. It can anywhere lie between 0 to 2 pi. Now my dear, let us assume that our point is present on the z-axis. As our title of the video suggests, let us now assume that the point is present on the z-axis. Now my dear, if point is present itself on the z-axis, then any vertical half plane making any angle with the positive x-axis is valid for that point. Yes or no? Any vertical half plane making any angle with the positive x-axis, any vertical half plane is valid for this point. Yes or no? Any vertical half plane is valid, because what is vertical half plane? It is the plane, that half plane, big half plane, vertical half plane, and it is attached to the z-axis. So now my dear, point itself is present on the z-axis. That means that point is present on any vertical half plane making any angle from 0 to 2 pi. Yes or no? So what my point is? What is the answer of this question? The answer of this question is you can take phi coordinate of such point anywhere from 0 to 2 pi, from 0 to 360 degree. The phi coordinate of this point may be 30 degree, may be 60 degree, maybe pi by 6, maybe pi by 4, whatever. The phi coordinate of the point present on the z-axis can be anywhere between 0 to, and my dear, here is the tip for you. If you are encountered with such point present on the z-axis, and if you are working in the cylindrical coordinate system, then you should take phi coordinate of such point. See, you can take phi coordinate anywhere between 0 to 2 pi. But you should take phi coordinate of that point equal to the phi coordinate of other point related to this point. Again I am repeating, you should take the phi coordinate of this point present on the z-axis equal to the phi coordinate of other point related to this point. You should copy the phi coordinate of other point which is related to this point. Now related to this point means what? For example, if you are writing distance formula, if you are finding the distance between this point present on the z-axis and the other point, then that other point is nothing but related to this point. So phi coordinate should be written equal to the phi coordinate of that point. In that case, your calculational complexity will be so much reduced, and your distance formula, you can easily find out the distance between these 2 points. Okay, so remember that though you can take phi value anywhere between 0 to 2 pi, you should copy its phi value from the other point, from the other related point. Okay, very simple. So this is how your phi coordinate of any point present on the z-axis. In the next week we will meet with another mind-bending concept. Thank you.